Hello everyone, welcome to my channel. Uh, this is an educational channel where we focus on theories of everything primarily that you've never heard of. Things that I've had the opportunity to do research on that are from people who, their work is in jeopardy of being lost to history. But I think that they have something important to say, and so I'm trying to put their stuff, get their stuff back out there into the public, so that people can toss around their ideas and extend them further. So today is video number 211 on the reciprocal system of theory, which is a theory that was first devised by Dewey B. Larson back in the 20th century. He started putting this together back in about 1930. Eventually wrote up his fundamental postulates, his two fundamental postulates in the 1950s, and then started writing books and wrote many books up until his death in 1990. Since then, a few other researchers have taken up the mantle and put out a lot of great work as well. We'll go through some of that stuff a little bit later, but right now we're focused on Dewey B. Larson's 1979 book called Nothing But Motion. And this book is primarily on atomic physics. We are on chapter 17 that is called Some Speculations. He's just kind of going into maybe where the theory is going and how to send it forward a little bit. Now, the basic idea behind Larson's system, the reciprocal system, is that this universe is a universe of motion. It's not a universe of matter. It's not a universe of energy, but a universe of motion. Matter and energy are two different kinds of motion. And all motions, all scientific, quantities, mechanical quantities, they're all forms of motion. And motion is a relationship between space and time. That sets up a generalized reciprocal relationship between space and time. Space and time are basically, two sides of the same coin. They are, Larson uses the analogy of a box. If you have a box, then you automatically have an inside and an outside of the box. And time is the inside of the box and space is the outside of the box, or perhaps vice versa. The box itself is motion. And you can see in the units that we were talking about, that everything, all these motions, they're basically a fraction, where time or space is the numerator and space or time is the denominator. But it is a little more complicated because space and time both come in multiple dimensions. This is what Larson refers to as coordinate space and coordinate time. We're used to the concept of coordinate space, three or more dimensions of space, XYZ coordinates. But in Larson's universe, time also has its coordinate aspects. So time also extends into 2, 3, or more dimensions. That's called coordinate time. And then time and space also have their clock aspects. We're familiar with the concept of clock time. The clock is always getting later and later and later, but it's moving in no particular direction. And that's, what Larson calls clock time, but there's also clock space. And clock space is the progression of space, or the flow of space. Space is always getting later, or I'm sorry, space is always getting farther and farther and farther apart. And this was observed by the Hubble telescope, before Larson even started writing up this stuff. All of the distant galaxies are moving away from each other, but in no particular direction. Just like if you had a balloon and you put a bunch of dots on the balloon, and then you blew up the balloon, all of the dots are moving away from each other. This is a representation of the flow of space, or clock space. You suck in the balloon, all of the dots are moving toward each other. That is an inward scalar motion in space. Scalar motion is a motion with a magnitude, but it does not have a particular direction, or you could say it has all directions. Space and time also are the same in that they both have their discrete units. There is no continuity of space and time. They come in chunks. There is a minimum chunk of space and a minimum chunk of time. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. So speed, we know, is space over time, space divided by time. The car is moving 25 miles per hour. 25 miles of space in 1 hour of time. Space over time. So that's how we see motion. In this particular instance, in the instance of speed, we can see that reciprocal relationship between space and time, 25 miles per hour. Now, let's say we wanted to double the speed. Then we would say the car is moving 50 miles per hour. But to show the reciprocal relationship between space and time, we can also say the car is moving 25 miles per half hour. If we wanted to double the speed, you can either double the space aspect, or you can half the time aspect. So that is the reciprocal relationship. Now, if we have 1 unit of space in 1 unit of time, we have the speed of light. Larson says that speed of light then is 1. That is the midpoint of the universe. In the same way that 1 is the midpoint of a reciprocal series. So if you have 1 as the midpoint, if you go in the positive, okay, now if you're in legacy science, 0 is your midpoint. And then when you go positive, you go 1, 2, 3, 4, 5. And when you go negative, you go -1, -2, -3, -4, -5. But if you're doing it reciprocally, you're using a multiplicative inverse instead of like a mirror image inverse. So a plus minus inverse, an additive inverse. And so you, instead of having 0 as your center point, you have 1 as your center point. And if you move in the positive direction, you go 1, 2, 3, 4, 5. But if you move in the negative direction, it's not -1, 2, 3, 4, 5. It is 1/2, 1/3, 1/4, 1/5. Those are the reciprocals. You have a reciprocal when they multiply together to get 1. And so in this universe where Larson is saying that 1 is the speed of light, that is the midpoint, and then above the speed of light, Larson refers to that as the cosmic sector. And that is the sector of the universe that we know very little about. But the below the speed of light is what Larson calls the material sector. And we know all about that universe from living in it, observing and measuring. And the scientists have done that. And that's why Einstein says that the speed of light is the maximum speed of the universe, is because he doesn't know anything about the cosmic sector, only the material sector. Now, what makes one thing that makes the reciprocal system powerful is that because of this reciprocal relationship between space and time, even though we don't know anything about this cosmic sector, this faster than light sector, we do actually know everything about it just by extrapolation. We know what's going on in the material sector, and we can extrapolate that what is going on in the cosmic sector is exactly the same as what's going on in the material sector, except that the roles of space and time are reversed. So in the material sector, we have coordinate space, 3 dimensions of space or more, and then we have clock time. The clock is always getting later and later and later. And that is what we're familiar with in the material sector. But in the cosmic sector, the roles of space and time are reversed. So we have, in the cosmic sector, the faster than light sector, we have coordinate time, 3-dimensional time, and clock space, the progression of space, just like on the surface of a balloon that is expanding. Okay, so that shows you that we can understand many things about the cosmic sector just through extrapolation because of the reciprocal postulate. Now, we're looking here at chapter 17 of this book, Nothing But Motion. We just got done with a few chapters on cosmic atoms. So a cosmic atom is the inverse of a material atom. In Larson's system, all atoms and subatoms are combinations of motions. What you have first is you have a photon, which is basically a simple harmonic motion. Now, that simple harmonic motion is two separate motions superimposed on one another. In Larson's system, the photon is a combination of a translational motion and a vibrational motion in a perpendicular dimension. So you combine these two motions and you end up with a sine wave. Now, some of Larson's followers have readjusted that and said that actually the simple harmonic motion is a motion of a birotation, two rotating motions. When you combine those, that also yields a sine curve. So regardless, we will discuss that controversy later. But the main point is that the photon is at the core of an atom. Actually, 2 photons is at the core of every atom. And then when you take those photons and you rotate the photons, that is how you end up building up to atoms, to matter. So an atom is really 3 different kinds of rotation superimposed on the photon. You have your primary 2-dimensional rotation, secondary 2-dimensional rotation, and then an optional electric 1-dimensional rotation. And so those 3 numbers go to make up an atom. And so in Larson's system, you use those same numbers or that same concept to understand a cosmic atom. But when he's talking about cosmic ray decay, a cosmic ray is an atom that crosses over into the material sector, and when it does so, it immediately begins to decay because a cosmic atom is not going to be stable in a material environment in the same way that a material atom is not going to be stable in a cosmic environment. And so it immediately begins to decay. And that's what he was talking about in these previous chapters. Now he's just kind of riffing on where the theory might be going in the future and so on. So let's start right here and read a few of these paragraphs. Subsequent studies of high-energy astronomical phenomena carried the development of thought on the subject of scalar motion in particular. Let me go back one paragraph. Okay. Even the simple concept of motion that is inherently scalar and not merely a vectorial motion, again, that's a motion with a magnitude but no direction. A vectorial motion is a direction, an arrow. Okay? Even the simple concept of motion that is inherently scalar and not merely a vectorial motion whose directional aspects are being disregarded involves a conceptual change of no small magnitude. And the first edition of this work did not go beyond this point, except in specifying that the increase in speed of recession of the galaxies is linear beyond the gravitational limit, a tacit assertion that the increment is scalar. Subsequent studies of high-energy astronomical phenomena carried the development of thought on the subject a step farther, as they led to the conclusion that the quasars are moving in 2 dimensions. However, it took additional time to achieve a recognition of the fact that unit scalar speed in 3 dimensions constitutes the line of demarcation between the region of motion in space and the region of motion in time. And the first publication in which this point was brought out specifically was the book Quasars and Pulsars from 1971, one of Larson's books. Now, we further find that the same considerations also apply to the incoming cosmic particles, cosmic rays. At the moment, it appears that the full scope of the subject has been covered, but past experience does not encourage a positive statement to that effect. This experience demonstrates how difficult it is to attain a comprehensive understanding of the various aspects of any new item of information that is derived from the basic postulates, and it explains why identification of the source from which the correct answers can be obtained does not automatically give us all of those answers. Why the results obtained by application of the reciprocal system of theory, like the products of all other research into previously unknown physical areas, necessarily differ in the degree of certainty that can be ascribed to them, particularly in the relatively early stages of an investigation. Many are established beyond a reasonable doubt. Others can best be characterized as work in progress. Still others are little, if any more, than speculations. However, because of the extremely critical scrutiny to which a theory based on a new and radically different fundamental concept is customarily and properly subjected, the publication of the results of the theoretical development described in this work has, in general, been limited to those items which have been given long and careful examination and can be considered as having a very high degree of probability of being correct. Almost 30 years of study and investigation went into the project before the first edition of this work was published. The additions and modifications in this new edition are the result of another 20 years of review and extension of the original findings by the author and others. Inasmuch as the results of this development are conclusions about one universe derived in their entirety from one set of basic premises, every advance that is made in the understanding of phenomena in one physical field throws some light on outstanding questions in other fields. A review such as that required for the preparation of this new edition has the benefit of all of the advances that have been made subsequent to the last previous systematic study of each area, and a considerable amount of clarification on the subject matter previously examined and extension of the development into new subject areas was accomplished almost automatically during the revision of the text, where it is evident that the new theoretical conclusions thus derived are firm enough to meet the criteria that were applied to the original publication. They have been included in this new edition. But in general, any new ideas of major consequence that have emerged from this rather rapid review have been held over for further study in order to be sure that they receive adequate consideration before publication. In one particular case, however, there seems to be sufficient justification for making an exception to this general policy. In the preceding pages, the discussion of the decay of cosmic elements after entry into the material environment was carried to the point where the decay was complete. And it was noted that the ultimate result would necessarily be conversion of the cosmic elements into forms that would be compatible with the new environment. Since hydrogen is the predominant constituent of the material sector of this universe, this element must ultimately be produced from the decay products. But just how the transition is accomplished has not been clear theoretically, and empirical information bearing on the subject is practically non existent. It would be a significant advance toward completion of the basic theoretical structure if this gap could be closed. Consideration of the question during preparation of the text of the new edition has uncovered some interesting possibilities in this connection, and a discussion of these ideas in the present work seems to be warranted, even though it must be admitted that they are still speculative, or at least no more than work in progress. Okay, that just gives you a little bit of an overview. We will continue with the rest of this chapter as we move on tomorrow. But for today, thanks for tuning in. And, take the time to go back over some of the previous videos, if possible, starting from the beginning and go through all of them. It's learning the reciprocal system is a process of building up. And you just have to, take it one thing at a time and build up your understanding, and sometimes things will click for you. Okay, have a great day. See you later.